So buses we know are made up of lots of parallel wires. So this is often known as your bus width. The amount of wires you've got is your bus width. Okay, so the amount of wires dictates how many bits can be sent at once. So if you've got 8 wires, you could send 1 byte at any one time. Now this length is known as your word size. So how big your word that can be transferred down that bus is. So the higher the word size, the more we can send at once. This can improve the performance of a computer, understandably. So to effectively use a 32-bit processor would say we have a 32-bit word size, typically on our data bus when referring to that, but the concept of the bus width is exactly the same. So now the more data, if we were focusing on what our address bus width, the effect that would have, the more data you can send down the address bus will affect how many memory locations you can reference. So as an example, if you say we're talking about RAM, the bigger our address bus is going to have an effect on how much RAM we can install, because we can only reference a certain, for example, let's make it really simple. If we had a 2-bit address book, so we had 2 lines, we've got therefore 2 bits, which means we've got only 4 combinations: 00, 01, 10, and 11. So we've only got 4 memory locations we can address, which means we can't install much RAM, because we can only address 4 locations. Even if you give me loads more, I can only use 4 of them. So obviously if we have a bigger address bus width, then we can install much more RAM, and then it's all the benefits of having more memory, as an example. So the bigger the address bus width, the better.